Hello, everyone. My name is Vitaly. I'm with the Robonomics team, and I'm here with Spot. And today we're going to talk about autonomy for cyber-physical system. Our little bit of a futuristic vision, but the one that we already are deploying today. And the specific angle we have on autonomy is like we see how there is a lack of economic tools and to integrate robots into human economy. So that's what we are focusing on. So let me start by telling a little bit of a history. We started this project 7 years ago, initially as a research project in academia. Most of the team's backgrounds is in robotics. So we saw how robots are becoming autonomous in operations. We saw advancements in computer vision, in motors, and we see all those cool robots. But we started thinking about the future trends and how robotics economy would work, how autonomy would get integrated into our everyday life. And we saw the lack of instruments. And luckily, when we started to think about that, Ethereum launched, and we started to show the first demos of how you could launch a robot under smart contract control. Back then, it was mostly drones, because drones were cool, and also because that was the cheapest robots we could buy, really. And then slowly we started to see limitations with Ethereum. So we started to move into Polkadot ecosystem, started working with Substrate and working more with industrial robots and robots like this one. So today I'm going to talk about less of a technical talk, I would say, but more of like a fundamental building blocks that I see, which components of Web3 are applicable and how they're seen from the robotics perspective, from the perspective of a robot, essentially. And first thing first, I think I'm fundamentally convinced that cryptocurrencies are actually native money for robots. They're not for people, really. They're digital inherently, they're programmable, and they're cryptographically secure. So cryptocurrencies are money for robots, really, and we just use them to transact with robots. But there's only so much you can do with cryptocurrencies with just transactions. So obviously, the second building blocks is smart contracts. And I don't know if you knew, but the term smart contract was first introduced in 1997 by Nick Szabo in his paper, Formalizing and Securing Relationships on Public Networks. And in his paper, he outlined two examples of how smart contracts could be used. First was a vending machine, and the second was a car leasing. And so we could think of a vending machine essentially that is community driven. So like all of us do transactions with a vending machine. It collects the money that it earns and then makes a refill of products for us using that money. And then the second example was car leasing, where he envisioned a smart contract where as long as the creditor continues to pay for the lease, they have access to the smart lock. And if the payments stop going through, then during the next ride, of course, it doesn't turn off straight away while you're driving. But then during next drive, you basically won't have access to your lock, so you won't be able to enter the car next time if you stop paying. We got inspired by this, and through the years of building Robonomics, we actually built very similar use cases to that. And one is a smart contract for leasing industrial equipment. So last year, we actually ran a project where we pulled some money together in crypto, and we bought two industrial robot arms, the ones that are like you maybe seen in the videos in factories. And we deployed them in a warehouse in Texas. So they are now packaging snacks and bottles and beverages. Kind of a boring use case. And we connected it to the Parachain. So all the data that is generated by the robots about the utilization is recorded. And the client is charged based on the utilization, essentially. So as long as they continue paying, the robot continues working. And it earns a salary, essentially, and distributes it to the money back to the people who funded it. And the second use case was more about access. So we recently worked with a small serve hotel in Mexico, where we connected a smart lock and all the infrastructure inside the hotel to the Parachain as well. And so now, essentially, like kind of an Airbnb, you can transact directly with a lock, unlock your room in the hotel, and you get access to your wallet, or based on the key in your wallet, we authorize your access for a day, essentially, or as long as you pay. And you can enter the hotel, unlocking the lock, but also get control of all the smart devices in the room as well. So like smart lights and ventilator and things like that. So essentially, we can have a secure validation point together with payment for accessing shared asset, essentially. And so the most important thing, that's kind of how it works. I guess we can scroll to the middle. So he sends a transaction, and once the transaction is posted, you can actually get control over all devices. Yep. And basically, we guarantee that only the person with a specific key in their wallet gets access to this infrastructure for a period of time. And the most important thing about here that I want us to remember is that, I'm getting asked a lot. Similar use cases can be built already with Web 2. The most important difference that I see is that with smart contracts, you have the economic part of transaction and the technical part of transaction in a single instrument. So it's essentially impossible to have a situation where the payment went through and the device didn't launch or something like that happening. We can guarantee that, and we can do this next slide. So we can guarantee that as long as the payment went through, the smart contract starts executing, and that same logic that is in that smart contract is basically the command for the devices themselves. With the Web 2 world, your payment infrastructure is completely separate, and your control over device is happening on some server. So payments go through payment network or bank, and then your control happens through some server. And that could be a mismatch. If we're talking about future of autonomous economy, we don't want to have a situation where there is the mismatch like that. Not even mentioning that we generally don't want to have a centralized control over all the machines. We all watch Terminator, right? So we prefer decentralized control of equipment. And then looking forward, I see, for example, in finance world, I see the trend in finance that our economy is already driven by robots and algorithms. I found these statistics for the forest market, but I think it's in general pretty standard that in finance, most of trading is essentially already happening with algorithms and high frequency trading. So in more traditional industries, like manufacturing or logistics, we're still not yet there, I would say. So there's a lot of talk that we're entering the fourth industrial revolution. And for those of you who are surprised, the first one was steam, second electricity, third was basic controller-based automation. And I think that most of the industry is still at this stage, at the third stage, because most of the robots, even that are deployed in manufacturing, are not connected to the network at all. So they're kind of dumb machines in the cage, essentially. So as we're moving to Industry 4.0, we start to have a situation where robots are connected to potentially consumer directly. So we could see and envision a situation where completely, what's called lights out factory could work autonomously with only robots there. So that means lights out. It doesn't need any light because only robots work there. And it builds custom products for us depending on our demand. And my claim is that Web3 is the perfect technology infrastructure to make it happen. So we already talked about cryptocurrencies being the native money for robots. Smart contracts can guarantee that the logic and the payments are together and guarantee the execution. And then over the past few years, there is a lot of advancement in different peering technologies, like Polkadot, where, for example, we got our Parachain right now, and we can start working with all the other different parachains that extend the utility of what we do. So we specialize in connecting to robots, but then, for example, the first parachain we worked with was Crust. They specialize on storage. So now, through an XCM, we can work with Crust, and our robots are sending data directly to Crust. And then the same way goes for identity, for compute, for financial use cases. So a lot of advancement there. But also, like, just peering communication technologies like IPFS, and for example, we use Yggdrasil network. It's IPv6 like peering communication technology. So it's just a lot of advancements that in peering technologies that make the infrastructure constantly available and secure to use in this autonomous economy of the future. And so the use cases. I talked about robots as a service. One of the more important use cases we also worked on was digital passports for products, where the robot can actually record the data about the products that it touches. So, for example, if we think about manufacturing of crypto wallets, I think that might be some topic that is relevant for all of us here. We want to make sure that nothing was planted when our crypto wallet was manufactured. So with Robonomics, you can have a system where every single step of the assembly process is recorded transparently, and you can make sure and see what was happening on every step of the way, all recorded by autonomous system itself. And then the final use case, the shared access to assets. That's what I want to do the demonstration with. We actually bought the Boston Dynamics robot because we saw that a lot of our robotics friends want to start developing on Spot, but not that many people could afford that. So we actually enabled a shared access to this robot. So now anybody who wants to develop their application with Spot, they can use our platform, connect to it, rent time on it, and start developing their own application, or even just learn the Boston Dynamics SDK. If any of you are interested, reach out to me after the talk. And so now I'm going to show you the demo and walk you through the demo of how we can actually remotely connect to Spot and authorize control of it. Hey. So we built a simple website. We're not really experts in front ends. So where first thing first, you authorize access based on the wallet, based on this private key in your wallet to this robot. And for this specific demo, we only allow specific lists of wallets that can access this robot right now. So that's why we do validation first. And then we demonstrate how you can actually pay directly to the robot. And we enable both credit card payments, where we have a kind of a token that is an API call, essentially. It's not public. Or you can pay crypto directly. And so now what we're doing is essentially we're paying directly to the wallet that is stored on the Boston Dynamics robot. And then we'll wait for about 10 to 15 seconds for the transaction to go through. And this browser will be authorized to start using the robot for 2 minutes, I think. So now we see the transaction was posted, so we can actually see the robot is starting to power on, the motors are turning on. And so I'm authorized to control it now. Yeah, he's very gentle with people, around people. And for this demo, we built different kind of moves and poses that it can do. Hello, humans. So yeah, basically, we have secure connection to the robot. And all the data that this robot is recording right now will be signed by the key in my wallet as well, encrypted, and stored in decentralized storage network as well. So this way we can have essentially a full, the full infrastructure for remotely connecting and operating devices in the real world using your Web3 wallet as your account, essentially. Hello. So we have, 1 second and it's off. So now all the data will be packaged and saved into Crust. Also demonstrating how amazing Polkadot network is. So that's kind of what we're working on. I guess if you're interested, I'm happy to answer a question. And also you can try the demo yourself in the meantime. If somebody is interested, you can try it out. We have some time, right? So yeah, feel free, please. If you're interested, try out the demo. You want to? Yeah, we need to pay the robot once again. And then in about 15 seconds, it will stand up. And yeah. It has its own node, it has its own wallet, so it actually listens to transactions. And yeah, it's an economic agent essentially itself. So like we as humans interact and transact directly with a robot. And that's kind of the idea that we are bringing with Robonomics, that we think robots need to be their own like kind of legal entity or economic agent at least. Yeah, so you can try it out. So WASD, like in games, is control, or you can do different poses like that here. So bow, for example, is the pose. But WASD is walking, and Q and E is turning. Yep. So I guess the most important thing is that we enable transactions in the economic layer for robots. And that's what you can theoretically enable in a similar way with Web 2, but your payments and your technical infrastructure would be separate. So we merge it together. And so essentially the robot itself or device itself is its own agent, and the transaction, the payment, and the technical code is executed inside the smart contract. So like there's no mismatch between the two, essentially. So if you're thinking about autonomous economy, for example, or like autonomous services, you can guarantee the execution essentially. If the payment went through, the execution is guaranteed. There is no guarantee like that in Web 2 world. So your payment could go through in a bank and then your server is down or something. That's one thing. Yeah, I mean, it's open source. Everybody can connect their own devices as well. Yes, on the same shared network. Yes. And everybody can also transact with these devices in the same shared network as well. However, there is no like centralized control over all devices. So like even though they're all on the same shared network, there's no like owner of the network, like with AWS, for example. Like if you're connecting all the robots to AWS, essentially, we could see a single point of failure there. Here, there's essentially no single point of failure because every robot is authorized to be controlled by a specific wallet. Yeah. So for this robot specifically, we do authorize only specific wallets to connect to it. So like you can, like even though it's connected to the network, it doesn't have to listen to all of us. So this robot doesn't. This robot will only listen to me. But yeah, you can, like for example, we have a use case with a sensor network for environmental data. And there, obviously, it's vice versa. Everybody needs to connect and get the data. And so I can deploy a sensor in my local area for air quality monitoring. And then everybody in the world can connect to my sensor and get the data. So it depends on your use case, really. We could make secure access, which is limited to specific people, or we could actually have a fully public access, but all still happening in the same network. Yep. Sorry. Yep. No, that's not. So we only authorize. We authorize access to the robot through a transaction, and then every single click we don't protocol in the blockchain. That's not really meaningful. Yeah. So we use peering network still, like P2P communication to pass those commands, but there's just local. Well, it's not local, but it's a communication between the peers. And this communication is only authorized when the transaction went through. So if the transaction doesn't happen, then I won't have access to this control. Yep. Yeah, we don't mint NFTs now. We have a kind of a separate demo where you can draw with spots and it mints you an NFT. But it works when it's in the lab, and now now it's only saved the data, so it's basically another demo. But it stores no, in IPFS it only stores the like the picture of the NFT. Yeah, and now it doesn't store anything because it's another demo. Yeah. But it does save all the data to like the launch transaction is in the blockchain, the log happens through Robonomics, and then the cross storage for all the data. So the video feed and the 3D map of the environment, the point cloud, were recorded to Crust. And we can see a transaction for it. Yeah. Thank you. Yeah. Well, that's what we think a lot about. So first things first, like we don't give access to the people. For now, for example, only I would have access to it. So that's kind of the basic security measure. So only the authorized people have access to this robot that is potentially dangerous. But then when it's shared access, so when it's in our lab, it's in a closed environment. So when people connect remotely and do their own development, it's just locked in a room basically, and it cannot hurt anybody. So yeah, we think a lot about security, and robots obviously could be dangerous. And yeah, there's different layers as well, like physical security, so that like when it's in operation, we try to keep it kind of closed usually. And on security, the software security layer, we enable access through the transactions or through your private key in the wallet. Yeah. Construction sites, inspections mostly. So like where it's dangerous for people to go and collect data, this robot is amazing. And it can walk stairs on terrain and stuff like that. So construction sites, nuclear power plants, even like caves, things like that. You can outrun it. Yep. So no, actually not. So as long as it's launched and the battery died in the middle, you still will be charged. But that's a good question. That's something for us to think about. Yeah. So for now, we didn't have a measure for that. And most of the robots we work with are connected to the net to like line. So industrial robots are always connected. So yeah, but that's a good question. Thanks. That one me. The value of it? Well, for example, we can, well, here it's just a demo, of course. But for example, if this robot worked in a construction site, the 3D map of the construction site could be protocoled as well. And that's basically an audit-ready record that could not be manipulated by people. So the robot captured the 3D map of the environment and then stored it with a blockchain-backed record, essentially. So there you can guarantee that the data that was recorded is the one that is valid, and you can use it in audits, you can use it for insurance claims, you can use it for many other things. But here, yeah, it's just a demo, and we kind of played around. Yeah. So where do you see this tech and sort of where you're going well, in general, I see a lot of advancements in robotics that are happening outside of traditional sectors like manufacturing. So for the past 30 years, most of the robots were deployed in some cage in manufacturing. So now robots are becoming much more smart and advanced, and they can actually start entering our everyday life. So in the next 5 years, I see more and more scenarios where we would transact directly with a robot, with a waiter robot in a restaurant, or like a robot that can bring you food in the hotel, or like a delivery rover that can bring you food again, or medicine, for example. Robots like these that capture data, I see a lot of them being deployed in the next 5 years. So I would say robots are coming out of cages and in our everyday life. And we need to start integrating them in our economy. That's the trend I see. Yeah. Yeah. Both could work, really. So for now, most of the use cases we have to build, and I think that that's going to continue, to be honest, because most of the clients for that still would be B2B and they expect a full solution. But most of the code is open source, so you can actually build it yourself, and we would love that. Like, because I don't, like one of the benefits of Polkadot ecosystem I see is like people building together. So we would love that. And if anyone of you is interested in building application on top of Robonomics, we are very much looking for these kind of people. I think that's it. Then oh. So that's the thing. Like, we can encrypt the data with your key. So like, and it's encrypted locally. So we can enable a solution where we don't see the data. Like, it's encrypted locally and then uploaded to the decentralized storage, encrypted with your key. So only you would be able to unencrypt it. Yeah. Not really centralized. So not yeah. This basically we can use the key to control access policies, but it's still the same shared network. So you are still in a public network. You would see the device, but this device won't accept your connection as long as you're not added to its list. So yeah, it's still public infrastructure, but still we control the access to only the people that yeah 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 yeah. Yeah, I mean, we still, for the blockchain part, we obviously need a internet connection. And if there is none, then it's kind of harder. The peering technologies that we use to control the robot itself, they won't work. They will work with without internet connection. But then the authorization, like, yeah, obviously, if there's no internet connection, we are kind of limited. Yay! Yeah. Well, thank you so much, and I'm happy to answer any questions afterwards.